Hello friends, welcome back. Today we'll see life cycle of a thread. We already know what is meant by a thread. A thread is a lightweight process, or it is an independent task that a program have. Okay, so which has its own flow of execution. So we'll see the life cycle of a thread. So whenever you say, okay, so my thread T is equal to new my thread, what happens is a new thread will be created. Okay, so whenever you say this line, what happens? It is in the new state. Okay, so after that, when you call the start method on T, like I am saying T dot start, what happens is the thread enters into the ready state or runnable state. Okay friends, when you say my thread T is equal to new my thread, what happens is a new thread will be created. It means that the thread is in the new state. After that, when you say T dot start, so the thread is in the ready state or runnable state. Later on, what will happen is you will be calling internally the start method will call the run method. Okay, so you won't be calling, we programmers will not write T dot run and all that. T dot start itself implicitly will call the run method. So when the run method is called, what happens is the thread is in the running state. When do the thread enters into the running state? Okay, so the thread will enter into the running state once the scheduler. So here the thread scheduler will be, okay, so playing the role. Okay, so what the thread scheduler will do is, it will have certain threads inside the thread pool, and the thread scheduler will pick one thread and then it will allocate the resources to that thread. When the thread is picked and the resource of the CPU is allocated to the thread, then the thread enters the running state. Okay, so this is regarding the running state. Okay, so once the run method is written, once the run method is complete, then the thread will enter into the dead state. Okay, so when do this dead state occur? If run method finishes off. Okay, so once the run method finishes, okay, so it is written, then what happens? The finishes, then the thread enters into the dead state. Okay friends, not only this, there are certain other methods like join, yield, sleep, wait, notify. So we'll see all that methods now. So yield method is a static method wherein a thread will voluntarily relinquish its control for the other threads with the same priority to get a chance to execute. So that is called as yield method. Okay, so the running thread when yielded, so this is static method, so I am saying thread dot yield. So when the yield method is applied, so it goes into the runnable state. Okay, so now we will see join method. Okay, so what is join method? Join method, say for example, I am having T1 and T2, two threads, and T1 wants to wait till T2 finished and then T1 want to resume back. So when T1 applies join on T2, so what happens is T1 goes into the waiting state till T2 finishes. Okay, so once T2 finishes, then T1 will start executing again. Okay, so this is the join method where one thread will wait for the other thread to finish. That is called as join method. And there are three overloaded join methods. The first is join, okay, and the second one is join with milliseconds, okay, and the third one is join with milliseconds, nanoseconds. Okay, so any of these join methods can be applied. So what happens is when the running thread applies join on T2, what happens it goes to the waiting state. Okay, so this is called as waiting state, or you can also say that this is blocked state. Okay, so the thread enters into the block state or waiting state when the join method is applied. Okay, now from this particular waiting state, when does it goes into the runnable state? So it goes into the runnable state when the join time, for example, we are saying that it is milliseconds and nanoseconds. When the time expires, okay, so when the time expires, it goes into the runnable state, or when T2 finished off. Okay, so since it has applied join on the T2, okay, so when T2 finished, then it goes T1 goes into the runnable state, and also in the third case when there is an interrupted exception if it is occurred, because join method throws interrupted exception. So if interrupted exception occurs, then it goes into the runnable state. Okay, so these are the three situations that may make a thread go into the ready state. Sleep method will pause the running thread for specific period of time. It can be milliseconds or it can be milliseconds comma nanoseconds. There are two overloaded sleep methods inside the thread class, and it is a static method. So say for example the sleep method is applied on the thread. Okay, so then it goes into the sleeping state. Okay, so it goes into the sleeping state. So from the sleeping state, when do a thread enters into the ready state? Okay, so the sleeping thread enters into the ready state when two things occur. The first one is when the sleeping time expires. Okay, it enters into the ready state, and the second thing is when an interrupted exception occurs. Okay, so if an interrupted exception occurs, then the thread enters into the ready state, or when the sleeping period expires. In those two cases, then the thread will be entering into the ready state. Next is the waiting state, friends. Okay, so when you apply wait on the current thread, okay, so it goes into the waiting state. Okay, so when wait method is applied, so what is this wait method? Wait method tells the current thread to release the lock and go to sleep. Okay, I will repeat this statement. Wait method tells the current thread to release the lock and go to sleep. Okay, so wait method, okay, so wait, notify and notify all. These three are the methods which are used for ITC, friends. So InterThread Communication, and these three methods are from the object class. Okay, so they are there in the object class. So don't confuse, they are not in the thread class. Okay, so the difference between sleep and wait is that sleep will not release the lock, whereas wait releases the lock and it goes into the sleeping state. Okay, so if the time expires, okay, so if the waiting time expires, or okay, so or there is an interrupted exception that occurs, because wait throws an interrupted exception. Okay, if an interrupted exception occurs, or if the waiting time period expires, or very important thing is if it gets notification. Okay, so if the thread gets a notification from the notify method, so in the or any of these cases, what happens is it goes into a state which is like waiting for the lock state. Okay, so waiting for the lock. Since it has released the lock, now to enter into the runnable state, it needs the lock. So what will happen is it will go into another state where it will be waiting for the lock on the object. Okay, and once it gets the lock, it again goes to the ready state or runnable state. Okay, so once it gets the lock, after it got the lock, okay, so once the thread gets the lock of the object, then it goes again to the runnable state. There are three methods which are suspend, okay, suspend method, resume method and stop method. Okay, friends, these three methods are deprecated. Okay, so they are deprecated methods, and they are deprecated from Java 2. Okay, so they are deprecated methods. What does it mean by deprecation? Deprecation means that they are no longer in use. Okay, the suspend method is deprecated because it will be causing serious system failures, because this suspend, for example, a thread is holding a resource and it went into a suspend state. The suspend state will not release the locks, so the other threads which are waiting for the resource may enter into a deadlock. So that's the reason the suspend method is deprecated. Now the resume method is linked with the suspend method. Okay, so when a thread is suspended to make it come back to the ready state or the runnable state, the resume method is used. Since the suspend method is deprecated, there is no use for the resume method as well. So that's the reason resume method is also deprecated. Now coming to the third method, which is the stop method. The stop method is deprecated again because of the same reasons, that it may create critical system failures. Say for example, the thread is writing something in a data structure, and suddenly it has made 75% of changes into the data structure, and suddenly we are stopping the thread. So the thread will stop and it enters into the dead state. But what happened to the data structure? The data structure is now in a corrupted state, and this should not happen. Okay, so that's the reason the stop method is also deprecated. Okay, but we'll just see into the life cycle of a thread how these methods will resume back and all that. Now coming to the running thread, the running thread can enter into a suspend state. Okay, so when it goes back to the ready state or the runnable state, so it enters into the ready state or the runnable state when the resume method is called. Okay, right. And coming to the stop, when a running thread stops, okay, a stop method is called on the running thread. What happens? It enters into the dead state. Okay, so these are all the methods, friends, and when we apply these methods on a thread, what happens to which state a thread goes, so all that we have seen in this life cycle of a thread.